Hello, I'm Alex Gruzen. I'm the CEO of Whitricity Corporation. I want to thank the organizers of this great conference of Solar and Storage and ChargEV for inviting me to speak today. I saw that the mission is to enable and accelerate the mass adoption of EVs, and that's really exactly the same mission that we have at our company, Whitricity. Whitricity is the pioneer of wireless electric vehicle charging. So actually moving electric power over the air, through the air efficiently. And we're focused on electric vehicles. The company was founded back in 2007 based on some inventions in the physics department at MIT. We're based in Watertown, Massachusetts, just up the river from MIT. And we developed a technology known as magnetic resonance. And I'll tell you a little bit later about sort of the specific sort of advantages and characteristics of our technology. We're a technology development company, which means that we develop the core technology. We transfer that technology to automakers and their tier one suppliers, basically enabling them to enter this business. And then we license it to them. That's our business model. We educate the automakers, we show them what's possible, we enable their supply base, and then we license the technology as it comes to market. Another very significant effort on our part is working with the global automakers to set global standards for the technology. To enable interoperability among all brands, and we've made some remarkable progress on that I'll talk about in a moment. We've specifically been working on charging for electric vehicles for over a decade now. In fact, since Toyota invested in us in 2010. So it's been a long, focused effort, which is really bearing fruits now, especially as the EV market begins to take off. So what we do is, we enable wireless power for electric vehicles that's as efficient as plugging in. So as a company, our goal, my goal for Whitricity is to make the act of charging completely transparent. It's just something that happens in the background. You park your car and it just starts charging. We think that that's the basis of a radical improvement in the whole customer experience of EVs. And what all of this, really the characteristics of our technology that make all of this possible is to have a no compromise experience, right? So with wireless charging, you're able to charge at the same speed, the same rates as if you had plugged in. In fact, the technology enables, charging from, tens of kilowatts to hundreds of kilowatts. There are no moving parts needed. So, nothing moving up and down or adjusting. You just park the car and it charges. Any vehicle height can be accommodated. So, with one common charger on the ground, you can have a sports car to a sedan, to an SUV, again, with no moving parts. You're not dependent on ultra precise, parking alignment. This is very different than what people, sort of experience today with sort of consumer electronics devices where you have to place a phone, say, on a pad in a specific spot. With magnetic resonance technology, you actually have positional flexibility. And that's what allows us to be so appropriate for the automotive case. You park the car, you can tolerate front, back, left, right offsets and varying Z heights. It's a primary characteristic of magnetic resonance, which is the technology we invented. Similarly, this flexibility applies to the charging pad and the receiver that's on the vehicle. The receiver can actually be smaller than the pad on the ground. That helps enable both parking flexibility, but also, fitting onto the vehicle. There's a lot of contention and competition for space on the vehicle. So we can have a smaller receiver and a larger ground pad, which is, again, a unique characteristic of our technology. The pad itself can be on the ground or actually embedded into the ground. The magnetic field that we use to move the power goes through materials. It could go through the asphalt or concrete. It can go through mud and ice and snow. It just really, the magnetic field just kind of goes through it without any interference and no loss of efficiency. So it's totally appropriate, for the urban environment, for snowy, wet environments, et cetera. It can be totally underwater, doesn't matter. Another really fascinating aspect of the technology, as you think about applications going forward, is that while everything I've said to you so far is about sort of what we call static charging, or in other words, you park your car and it just charges, we've also proven that the technology can work at speed. So what we call dynamic charging, where you could outfit a lane of a freeway with charging, embedded charging, and as the vehicle moved at speed, it could be charged. In fact, that technology has been demonstrated over 100 kilometers per hour on a test track. Now, from a practical point of view, I think it's, we would need many years, really, frankly, to have enough density of wirelessly charging equipped vehicles to justify installing that on your typical highway. But I think in a much sooner time frame, much more realistic time frame, you could imagine equipping a taxi queue, a queue at a train station or a queue at an airport. So electric taxis could, say, maybe just for 100 meters, as they inch along, waiting for their passenger, be topping up and charging. So I think that application is absolutely practical and will happen in the near future. Another thing that I think is a future opportunity for EVs in general, but in particular for wireless charging, is this concept of vehicle to grid. About a year and a half ago, we demonstrated with Honda at the Consumer Electronics Show in Las Vegas, wireless vehicle to grid. And so the fact that, a industry standard compatible charging system could send the power both, to the vehicle to charge it, but equally back to the grid when needed. And why I think wireless is particularly important here is because, when that battery is most useful to the grid is when it's charged. And when it's charged, many people don't bother to plug in. But with wireless, it's sort of not an issue. Anytime the car is there, anytime it's just in a parking spot, with no user intervention, they didn't have to remember to plug it in or not, that battery capacity could be available to the grid. And I think it opens up some very new and exciting business models. So everything I've just described to you came out of research at MIT and also some tremendous research at the University of Auckland in New Zealand. Witricity was founded out of MIT, a great company known, many of you may know, Qualcomm, invested in this technology as well, based on the research at University of Auckland. And Qualcomm for the past decade has been pushing as well as Witricity for commercialization of this wireless EV technology. I'm really proud that about a year and a half ago, Witricity acquired that Qualcomm Halo business, and we were able to kind of consolidate the industry and consolidate the intellectual property portfolio and sort of the best of breed technology from both sides. And that move to kind of consolidate the technology roadmap has resulted in tremendous momentum behind setting the global standard. As I said, we've been working towards setting global standards for about 10 years. 2020 was really a remarkable year in setting the stage for wireless electric vehicle charging. In May, the Chinese National Standards Organization, often the standards coming out are referred to as GB standards, in May published the GB standard for wireless electric vehicle charging, built on our technology foundation and our essential intellectual property. And then just a few weeks ago, in October, end of October, the SAE, the Society of Automotive Engineers, published the global standard. Now, this isn't just something that Witricity makes up. I mean, this is something that over 10 years, all of the automakers and all of the suppliers to the automakers, technology companies within the automotive space, all have been working, over 250 participants over the course of 10 years, to set this standard. And the standard is so important because it enables interoperability. And it means that the automakers have voted that this is the approach to hands-free wireless charging for the future. And interoperability is important because it doesn't just mean that sort of my car and my wife's car could both charge off the same charger in our garage. Well, that's important and that's positive. It's not enough, right? So what it really means to me is that infrastructure, public infrastructure, can now be built because there's confidence that any vehicle that gets equipped with wireless charging will work off this common standard. The SAE standard is known as the J2954 standard for wireless electric vehicle charging. And it's an exciting stage. We now have multiple automakers committed to production in the next couple of years, and we're off to the races. So really exciting time for us. Underlying these standards, as a company, we have over 1,000 issued patents, and we license that as a consolidated portfolio to the industry, whether it's automakers themselves, they're what's known as tier one suppliers, the supply chain partners for the automakers, or to companies doing charging solutions for heavy-duty electric transit buses or heavy-duty trucks. It's all built on our intellectual property, our patent portfolio. And we also do significant technology transfer of reference designs and solutions for all of these partners in the space. The standard is set, the OEMs are going to the market, and really now we're into the phase, moving out of the phase of development and into the phase of deployment. Now, some of you may have seen an initial deployment a couple of years ago, built on our technology from BMW. That was the 530e i performance. That was a fantastic plug-in hybrid. Just earlier this year, McLaren on their Speedtail hypercar, that car ships standard with wireless charging. Again, an application of this technology. You may have seen some videos from Hyundai promoting how wireless charging can fit into self-parking, their sort of auto valet feature, which is just sort of a fantastic application of wireless charging. You go to send the car off to park itself, it parks, it charges, and then you call it back. Now, kind of impossible to do without wireless charging, right? If the car is plugged in, you can't signal it to come to you. And if you send it away, it just can't charge. So if you haven't seen any of that, go ahead and look on YouTube for Hyundai Auto Valet or for BMW wireless charging. You can get a great feel for the work that we do. Several automakers are moving into production in the next few years, both from all countries of the world. You'll see the technology in Europe, in the United States, across Asia, and a very significant push in China. As you may know, China has really made a national commitment to electrification of vehicles, and wireless charging is part of their sort of national plan. Um, so what, so let's just talk briefly, like why does all of this matter? So first of all, I think fundamentally increasing EV adoption is important. I mean, changing consumer behavior isn't easy. I've spent over 20 years developing products in the consumer market, and I think that this act of charging, having to proactively think about charging, is something that is sort of causing resistance to mass adoption of EVs. So I want to make charging just something that happens in the background. It's just a transparent act. Whenever you come to your car, it's charged and ready. And given 90% of the driving people do is within the range of the vehicle, you pretty much could own the vehicle and never have to think about its range and never have to think about charging if you had wireless charging. So we think that capturing mainstream consumers and bringing them into electric vehicles, wireless charging plays a key role. I think that DC fast charging will continue, but I view that really as about sort of range extension. I have a long trip. Can I get to grandma's house, right? Yeah, you're going to pull over to the side of the road and you'll want to charge quickly. But with wireless charging, for all the rest of your driving, you'll just never have to think about vehicle range at all. So that's exciting. I think wireless charging plays a key role in car sharing. So think about shared vehicles returned to their parking spot and always being ready for the next customer. You'll never go to a car and realize the prior customer didn't bother to plug it in. In fact, BMW already rolled our wireless charging out in a fleet of 200 vehicles in Chengdu, China, for exactly this purpose. Car sharing really made perfect. This technology scales up to hundreds of kilowatts of power. And so I think an important market is transit buses. Buses have a fixed route. You would not have to put charging all along the route. A couple of strategic charging spots en route, maybe where there's a driver shift change, for example, or where they get a coffee break, would allow that bus to operate 24/7 on the route, whether it's heat of summer with air conditioning running or cold of winter when the batteries are a little bit less efficient, and would eliminate having to take that bus off route and send it back to the bus barn for charging, right? So this is absolutely a total cost of ownership play, where fewer buses needed, potentially even smaller batteries on the buses, and the ability to run full-time all season on that bus route with no maintenance, no moving parts, no cables, no mess, no vandalism, no extra tasks for the driver. So I think that's a big win. Taxis, I talked a little bit earlier about the idea of a taxi queue. Well, in electric taxis, a lot of the drivers don't live in the city where they, give rides. They live somewhere out in the suburbs. They consume energy coming into the city. And they have less range for driving around and earning money. So in that sense, many taxi drivers are hesitant to shift away from internal combustion engines and go electric. Well, if we can make these taxi queues a simple part of their day-to-day business, it's at the train station, it's at the airport, and they're topping up as they go, then suddenly, all the cost benefits and the environmental benefits of electrification really play to become a strength for the taxi driver. So we see wireless charging being a critical element. The driver doesn't want to go away somewhere to plug in to charge for an extended period of time. That's time they should be earning money. If we can embed it in their day-to-day routes, and make it a transparent part of their operations, then electrification is a huge win, both for the environment as well as economically for those taxi drivers. And really everything I've said so far is setting the stage for autonomy. Right? So, fundamentally, in all of our conversations with the automakers, one of their core reasons they are investing in this technology and core reasons why setting a standard was so important to them was that the future is autonomous. And we know that it will need a hands-free methodology for wireless charging. You need the ability for that robotaxi or that autonomous delivery vehicle to be able to just pull over, whether it's waiting to get loaded or it's en route waiting for its next ride. It needs to just be able to pull over and do what I call power snacking, right? To just periodically through the day as needed, top up its batteries in a way that has no human intervention, right? I mean, the whole point of autonomy is to reduce the costs and to take the driver sort of out of the equation and make more vehicles more plentiful and available for faster rides, more availability and delivery. In fact, I read recently that in the UK, something like 5% of groceries pre-pandemic had already shifted to home delivery, that in the pandemic it had grown to, it doubled, it had grown to 10%. So I think that there's going to be a lot of activity in autonomous guided vehicles, delivery robots. I think that's a huge area of investment, again, really ripe for wireless charging as a perfect solution. So, ultimately, this is, all of these things I've just described are key elements of what will be the future smart city. Autonomous people movers, car sharing, personal mobility like e-bikes and e-scooters that could just be set down and charged. And of course, broad adoption of electric vehicles into people's homes with a ownership experience that can be so much better than it ever was with gasoline engines. I mean, why do we want to reproduce the task of having to go someplace to charge when we can make it so simple and transparent where they park at home or at work? So thank you for the opportunity. I hope you have a great conference, and I look forward to hearing from you if you have any questions about wireless charging for vehicles. And appreciate your support as we roll this new technology out into the market in the coming couple of years. Thank you.